So we're working on weather variables. We're in our textbook at page 165 to 169. This reading is already on Schoology. And we're following along with the guided notes that are also provided on Schoology. Okay, so I'm going to scroll down and following along with our finger or our pencil. What is weather? Everybody talks about the weather. Nice day, isn't it? How was the weather during your vacation? Talking about weather is so common that we even use weather terms to describe unrelated topics. That homework assignment was a breeze, or I'll take a rain check. Weather is the atmospheric conditions along with short-term changes of a place at a certain time, of a certain place at a certain time. If you've ever been caught in a rainstorm or on what began as a sunny day, you know the weather can change quickly. Sometimes it changes in just a few hours, but other times your area might have the same sunny weather for several days in a row. Weather variables. Remember, a variable is something that can change. So these, like we said, weather changes, right? Tropos means change. The troposphere is what gives us weather. So perhaps some of the first things that come to mind when you think about the weather are temperature and rainfall. As you dress in the morning, you need to know what the temperature will be throughout the day to help you decide what to wear. If it's raining, you might cancel your picnic. Temperature and rainfall are just two of the variables used to describe weather. Meteorologists, scientists who study and predict weather, use several specific variables that describe a variety of atmospheric conditions. These include air temperature, air pressure, wind speed and direction, humidity, cloud coverage, and precipitation. So air temperature. The measure of the average kinetic energy of molecules in the air is air temperature. When the temperature is high, molecules have high kinetic energy. Therefore, molecules in warm air move faster than molecules in cold air. Air temperature may vary with time of day, season, location, and altitude. What's altitude? What's altitude, Fabio? How high you go? If you're higher up, what's the temperature like? Corey. It's colder, right? All right, so we're gonna go to our notes. We're gonna find the section. We're gonna find the section that says air temperature. I, on purpose, did not put it in order to make sure that you were paying attention. Yep. So before I do that really quick, I'm also gonna write my website on here. If you Google Miss Burley, I'm actually so famous. Just kidding. I am the first thing that pops up on Google, my YouTube channel and my website. But these notes are already completed under Unit 3 on my website. You also have a link to this same website on the homepage of Schoology for this class. So you have a link to my YouTube channel, and you also have a link to my website on the homepage for period 7. Yes. Okay, so maybe I need to go a little bit more famous then. So it's always the first thing. So we're gonna go to where it says air temperature, which is the first one on the bottom. This one's the one we're most familiar with. This is the one we're most familiar with. And we're just gonna fill in the blank. So it's the measure of the average kinetic energy of air molecules. What is kinetic energy? Who remembers from last year, Fabio? It's the energy of motion, yeah. When you let it go, right? A spring before that is actually gravitational potential energy. So before we kind of talk about what it's measured with, I want to define it because next unit we're going to talk a lot about kinetic energy. Yes, anything I write, you write. So this is the energy in an object due to motion or due to its motion. You may have heard of the word kinesthesiology. That's the study of motion. If you haven't, that's okay. But we should have background information from last year about kinetic and potential energy. If you don't, and this is the first time, then this is something you need to make sure you look over because we need to be ready to work on it next year or next unit. Yeah. Kinetic energy is the energy in an object due to its motion. If an object, really quick, everybody stop what you're doing. Freeze! Are we moving? No, right? Because when it's colder, is there more or less kinetic energy? Less, right? Now put your hands together and rub them together real fast. Real fast. So the faster I move them, so the more kinetic energy, what happens to my temperature? It gets hotter, right? So the way I think about it is that if I'm frozen, there's no movement, right? So the colder something is, the less kinetic energy. The more something moves, the more kinetic energy it has, the more heat it has. So if it's hot outside, there's going to be more kinetic energy. If it's cold outside, there's going to be less kinetic energy. This is important for you to write. No, because those molecules are always moving. We'll talk more about the difference. I need you to write what I wrote, please. Thank you. Eder? I'm hearing a lot of side conversation and need to make sure we're staying focused. This is measured. What do we measure temperature with? What do we measure it with, Wilson? If you're sick, what do I take your temperature with? What do I take it with? What is it called, Bo? A thermometer, because that word therm means heat, right? Now, you guys know I like to take pictures or like to draw pictures. So you can either draw it like this. And for the first year ever, we can also draw the thermometer like this. So the ones from Carla, yeah. So for the first year ever, we can also do it like that. But you know, it typically does not look like that. If you don't want to draw the pictures, that's fine. I will require you to draw the pictures for 2 of them though. At least draw this one, because you need to know what they look like. We know what a thermometer looks like, but I do need you to draw them for 2 other ones. So temperature is just a measurement of the kinetic energy in air molecules, how fast those air molecules are moving. A thumbs up when you're ready to go. Oh, that's why I asked for the thumbs up. All right, so we're gonna move on to the next section. I can give them a copy to finish at lunch. So just follow along with us. You just missed the very beginning part. So we're reading about air pressure. Okay. The pressure that a column of air exerts or puts on the air or a surface below is called air pressure. Study figure 1. Is air pressure at Earth's surface more or less than the air pressure at the top of the atmosphere? Air pressure decreases or goes down as altitude goes up or increases. Therefore, air pressure is greater at low altitudes than at high altitudes. You may have heard the term barometric pressure during a weather forecast. Barometric pressure refers to air pressure. Air pressure is measured with an instrument called a barometer, shown in figure 2, which is at the bottom of the page. Air pressure is typically measured in millibars. Knowing the barometric pressure of different areas helps meteorologists to predict the weather. So I'm going to kind of take this back a second. We're going to go to where it says air pressure on the front. Go to where it says air pressure on the front. All right. I gotta move this so my mobile friends can see, so you won't be able to see me for a second. But all right, so I want you to think about it like this. The ceiling is gonna be the top of the atmosphere, all right? And where I'm standing right now is the lowest point I can go. I'm on the ground, okay? So the distance between me and the atmosphere is the highest, at the highest point that it will be, right? There's more distance between me and the top of the atmosphere than there will be at any other time. So my altitude is low, but the distance between me and the top of the atmosphere is high. Okay? So if you think about that distance as pressure, the amount of distance or the amount of pressure from the top of the atmosphere pushing down on me is greater, right? I have more pressure from all the way from the ceiling down to my shoulders pushing me down, right? All right, now think about it like this. I'm okay. I'm fine. All right, so mobile friends, I'm standing on the ceiling. Or not standing on the ceiling, but I'm standing on the desk. My altitude is now what? Higher, right? But the pressure between me and the top of the atmosphere is closer, which means it's lower, right? Because the distance between me and the top of the atmosphere is lower. There is less pressure pushing down on my shoulders. Does that make sense? Similarly, if I think about swimming, okay? If I'm deeper down in the water, what is my altitude, greater or lower? Lower, right? Because I'm lower in the pool. My altitude is less. But don't you feel more pressure? Mr. Holsholt, our principal, actually scuba dives, okay? And he and I have talked about this before because his lungs, you have to work your way up to going deeper and deeper and deeper because your lungs start to feel compressed. Like, everybody take a deep breath. The lower you go, the harder it is to breathe because that pressure it's heavier. It's almost like having bricks on your chest. Does that make sense? So let's rephrase this really quick. The lower you are, the air pressure is higher, right? The higher you are, the air pressure is lower. Does it make sense if I give you visuals like me standing up and seeing the distance? Okay, yes. Yes, that's exactly what I was showing in terms of me standing on the desk close to the ceiling. That's okay.
Miss Burley, you're on mute.
I know, they were getting their lunch.
Oh,
So I
okay.
put it on mute. This is my scuba diver. That's my scuba diver. My first one was much better. Yeah, this was my first one. That was Mr. Holschult. All right, so we'll do this one. All right, look, I was rushing. So as air pressure decreases, as altitude increases, we said talk about swimming, right? Or think about swimming. The lower the altitude or the deeper I go, the more pressure I feel. This is measured with something called a barometer. Just like your blood pressure. Have you ever seen a blood pressure cuff? I'll show you a picture. I'll wait. A blood pressure cuff is what they put around your arm. It gets tighter when they squeeze it. A bike tire pressure gauge looks the same exact way. All of them measure pressure. Actually, a blood pressure cuff's real name is a sphygmomanometer. Sphygmomanometer. But I'll wait. If you remember barometer and blood pressure or bike tire pressure, I feel like somebody is talking after me every single time. Can you stop that? Thank you. It will help you to remember, just like we worked on meteors in the mesosphere, right? But I do want you to draw what a barometer looks like, because I'm going to show you what a blood pressure cuff looks like, and it'll help you to make the association in your brain. Yes. You don't have to draw the scuba diver. You don't have to draw Mr. Holschel. Yes. It's, yes, same thing, right? But think about it in terms of air pressure. When I'm lower down, it's air on top of air, right? Like pushing down. So same thing. So really quick, just so you guys can see what a blood pressure cuff looks like, this is called a sphygmomanometer. I don't know how that name got made, but do you see how the cuff, if I click on this one, I just clicked on one. Oh, it's okay. I can't buy any medical supplies, I guess. We're not talking about the automatic ones, but it is the same gauge here, right? It just measures pressure. A bike tire gauge, a bike tire pressure gauge, is the same thing. So here's a bike tire one. You'll see that it looks the same exact way, right? They all look the same way. So if you remember blood pressure or bike tire, it'll help you remember barometer. Well, I just showed you, so now you know. I'm going to give you about 30 seconds to finish this up. Like I said, you don't need to draw the scuba diver. We're not focused on the lunch right now. Like that. So it's the pressure that a column of air exerts or puts on the air surface below. So the fact that air is pushing down on you. More distance between you and the top, more air pushing down on you. All right, so I'm going to go ahead and move on. I've given plenty of time. All right, so we're going back to our reading. We're reading about wind. So as air moves from areas of high pressure to areas of low pressure, it creates wind. Wind direction is the direction from which the wind is blowing, so where it's coming from. For example, the westerlies blow from west to east. Meteorologists measure wind using an instrument called an anemometer. An anemometer is also shown in figure 2. So I have a barometer and an anemometer. These cups, just like when you're swimming and you cup your hands, they tell you to cup your hands when you're doing a hand stroke, a front stroke, they catch the water and propel you forward, right? So this catches the air and moves it forward. How many of you have ever seen The Wizard of Oz? Okay, all right, this Listen, this one's a little bit of a stretch, the way I remember this one. But I always think, you see how it's spelled, an anemometer is spelled, like, it says, like, it looks like it says Annie, right? A-N-E, Annie. And doesn't Dorothy live with Annie M? Or Auntie M, Annie M? So I always think about the tornado and how that's just high wind, and I think Annie M, Annie M. So I see Annie M. Hey, Annie M. And that's measures wind. And also, I remember that air moves from areas of high pressure to low pressure, because, really quick, freeze for a sec. How many of you like high pressure situations where there's lots of stress? Okay. How many? So most people like areas, like it when it's low pressure. You can just stop. So, well, so does wind, or so does air. They want to move from areas where it's really high pressure to areas where it's low pressure. Also, H comes before L in the alphabet. So I think like H to L. H comes before L. So H before L. High to low. Go ahead. I do want you to attempt to draw the anemometer, only because I want you to know that the cups are what's catching the wind. But if the Annie M thing doesn't help you to remember that's what measures it, then you got to find something on your own. Yes. Yes. So in The Wizard of Oz, what causes Dorothy to go into the land of Oz is a tornado, right? And she lives with her aunt named Auntie M. So in the movie, when the tornado comes, she yells, Annie M, Annie M. And tornadoes are just high wind. So I think Annie M. That's okay. I mean, like, just like I said, if it's not something that helps you remember, then don't use it. But if it helps at least one student, then I'll go for it. Yes, Corey. What's what called? An anemometer. Anemometer. Barometer measures blood pressure. Or really, it's air pressure, but I think of blood pressure or light pressure. And then I think of an anemometer as like Annie M, the wind. But just like these are all new words to us. It's not like all of a sudden I woke up one day and knew what these words meant. I had to find ways to make my brain learn them. So we love taking the easy way out. Make it easy for your brain to remember them by giving it tricks associated with stuff that you already know. That's not cheating, that's just called being resourceful. All right, since we're talking, you're showing me that we're done. All right, so then we shouldn't be talking. I want to make sure that you guys have these notes so that you're ready to do your online lab on Thursday. Because you're measuring all of these weather variables in different scenarios, so you need to be familiar with them. So if we look at our reading, our next section is humidity. So I'm going to read relative humidity and regular relative humidity and regular humidity together, and then I have a demonstration to show you to try to help with understanding what those are, okay? All right. Humidity. The amount of water vapor in the air is called humidity. Humidity can be measured. I see people who aren't following along. Thank you. Humidity can be measured in grams of water per cubic meter of air. When the humidity is high, there is more water vapor in the air. On a day with high humidity, your skin might feel sticky and sweat might not evaporate from your skin as quickly. Is it humid in Florida? Why? Why, Jalen? We're surrounded by water, so it's constantly picking up water, right? I think I talked about this before when we were learning about the water cycle, but when I lived in Texas, I was landlocked. I didn't live near any water. And so it was a different kind of heat. It was hot, but it was dry. Now, if I go outside and whenever my sister comes to visit, I mean, she's from up north, but she's not surrounded, it's not the same amount of water. She's only on one side near water. But she literally says, I feel like I showered in my own sweat when I walk outside in Florida in the summertime. Doesn't it? Because you feel so sticky and gross. And that's just because it's almost like you are just walking through water because there's so much water in the air. But when we see the amount of humidity in the weather, we're actually not looking at humidity itself. We're looking at something called relative humidity, right, Cedric? All right. So relative humidity. One second. Okay. Relative humidity. Think about how a sponge can absorb water, right? At some point, it becomes full and cannot absorb any more water, and it'll start to drip, right? What would that dripping represent in terms of weather? Think about the sponge as a cloud and it absorbing so much water that it starts to drip. What would that be considered, Jotan? Like raining. Very good. In the same way, air can only contain a certain amount of water vapor. When air is saturated or full, saturated means full, it contains as much water vapor as possible. So when it's so full, what's going to start to happen? Very good. Okay. Very good. Temperature determines the maximum amount of water vapor air can contain. Warm air can contain more water vapor than cold air. The amount of water vapor present in the air compared to the maximum amount of water vapor the air could contain at that temperature is called relative humidity. That's a mouthful, but I'm going to break it down for you. Okay? Relative humidity is measured using an instrument called a psychrometer and is given as a percent. For example, air with a relative humidity of 100% means it's 100% full. It can't hold anymore, right? So if it's 100% full, what's going to start to happen? Precipitation, right? Or you're going to have dew, which is what you wake up in the morning, right? And it's not hot enough, so it's still on Earth's surface, and the ground is wet, or you might notice it on your car. Air that contains only half the water vapor it could has a relative humidity of 50%. So let's think about this. I want to make sure you understood what I just said before I demonstrate. If there is 25% relative humidity, how much more water vapor could the air hold? If it's only 25% full, how much more water vapor could it hold? Whoa, 75%. Okay, so this is my demonstration, so bear with me here, okay? All right, let me get back to you. Let me do this first. Okay. The red cup represents warm air. Okay, remember, warm air can spread out. It's a gas, right? We want all air as a gas, but imagine it this way, okay? It's more spread out. When it's cold, just like when we're cold, we condense. Does that make sense? So my cold cup is smaller. It's condensed. Everybody follow me here. All right. This isn't all the way full. It's about right here. Verify that for me, Fabio. All right. Verified. So it's about this full, okay? We said warm air can hold just as much, or it can hold more. So my cup is physically larger. My cup is physically larger. If the temperature starts to drop, but I have the same amount of water vapor in the air, right? It's not like the water vapor just disappears. It's still there. What do you think is going to happen if the temperature starts to drop? If it starts to drop, it gets colder. Same amount of water vapor in the air, but it gets colder. What do you think is going to happen? Think about it. This water, it's warmer. It's going to get colder. So all of this water's got to go in this cup. What's going to happen? Corey? It's going to overflow, which represents what? Precipitation. So watch. Same amount of water vapor in the air. Temperature itself gets colder. Think about why overnight it starts to dew. And I wake up in the morning and there's dew on the ground, right? Same amount of water vapor in the air. It just got colder, right? So same amount of water vapor. It's warm. It's getting colder. It's getting colder. Same amount of water vapor. Same amount of water vapor. But at some point, it gets 100% full and it starts to precipitate, right? Think about it this way too. The same amount of water vapor in the air. Yesterday, it was yesterday night. But when I woke up this morning, I let Dolly out, the ground was wet, right? The only reason that's like that is because the temperature itself was colder, because the sun's gone. Does that make sense? In the summertime, though, it still rains. So why does it still rain so much in the summertime? Use what we already know about the water cycle. Why does it rain so much in the summertime? Tiffany? Yeah, more water's being evaporated. But it also rains in the wintertime. Why does it rain in the wintertime? Based on what I just showed you, why is it going to rain more in the wintertime? Or not more, but why does it still rain in the wintertime? Somebody new. What do you think? Anybody mobile have an idea? I'm about to give it to Fabio. All right, go. Or fall or winter, yeah. Think about the figurative cup. Think about the figurative cup. And when it's colder, fall, winter, the cup is smaller. So it's more going to overflow more frequently. Does that make sense? So it rains a lot in the summertime because more water vapor is actually in the air. It's being evaporated. But even though the temperatures are colder, it's not evaporating as much water. It can't hold as much. It has a smaller cup. So it still rains. It fills up faster. Does that make sense? Okay. That's a pretty complex concept. So if you're still struggling with that, let me know. But, ooh, it's okay. We're not going to do the cloud part, guys. So don't worry about that. But we're going to finish off with humidity and relative humidity. So humidity is the amount of water vapor in the air. If it's more humid, there's more water vapor. And just like we said, Florida is typically very humid because it's on the coast. It's picking up more water. And in the summertime, it's evaporating more because the sun is out, right? I will in a second. Bless you. Now, what does the word relative mean, by the way? What does the word relative mean, Mark? Think about somebody who is your relative. What does that mean? Family. It means that you are related to them, right? It means you're related to them. So relative humidity is related to or based on the temperature. It's related to or based on the temperature. And it's always given in a percent. It's percent full. It is 79% full. It is 100% full. Is everybody done with the humidity part? Okay. All right. All right, that's what we're working on right now. So, and I even drew my cups. Warm air holds more than cold air. Like the cup itself is bigger. So even though more moist, it has to be bigger because if it's warm, more water is being evaporated. What? The cups? Oh, I messed up on something. I messed up on something. It's okay. So I looked at the weather earlier. Let's see if it's changed. Oh, it has changed. Let's see. Oh, no, it hasn't. Okay, hold on. It's all right. I'll check. All right, so look, just really quick, because I just checked it less than an hour ago. So it's 72 degrees. This humidity is actually relative humidity. Somebody explain what it means by 79%. What does it mean by 79% based off of what we just said? Somebody new. I'm getting the same people over and over again. I want somebody to try. Think about what we just wrote. What does it mean? What is this? Oh! Yay! Okay, all right, watch this, okay? If 100% relative humidity means it's 100% full of water vapor, okay? So this is just between, it just took time to load. Okay, so earlier today, it was 72 degrees, all right? Let's be scientists for a second. So earlier today, it was 72 degrees, all right? And the relative humidity was 79%. Okay? Now, it's 77 degrees. Do you think that the relative humidity is going to be more or less? Somebody tell me why less, Bo. Yes. All right, so think about this. Same amount of water, right? So I've got my cup. Same amount of water, it's 79% full. But now my cup is larger because it's a higher temperature, right? Same amount of water, but it doesn't fill up near as much of the cup. So let's see if we're right. Let's see if we're right. Look, 68%. Does everybody see what I mean here? Same amount of water, but the cup is not as full because it's bigger. It can hold more. That makes me so excited that it worked out. All right, I'll let you go. Yes. Because I've been waiting for it to change so I could show you how it really works. Because when we look at the temperature and it gives us a percent humidity, it's actually showing us relative humidity. But until right now, we were today years old when we realized that that's actually relative. It's based on we were today years old when we realized it was based on a percent, which means it's relative humidity because it's relative to temperature. So just like I said, the temperature was less, so my cup was smaller. It filled up more of my cup, 79%. 77 degrees is warmer, which meant my cup got bigger, and the same amount of water took up less space in the cup. It was less full. Thumbs up if you feel like that was explained in a way that was clear enough for you to understand. Okay. If you're still struggling with that, that's okay. It's a hard concept to learn, but think about the different size cups, and I think it will help. If you want, you can even write our example that we took literally real time today. Yes. Once you have this done, we're not going to do the clouds part right now. So this section right there with the clouds, don't worry about that right now. I'm going to put it up there because I'm actually not assessing the cloud part. I really want us to focus on the idea of weather first. So once you finish this, make sure you submit them, only the front and back of this page, not the cloud part, in Schoology, and that's what I'll check for you guys. My mobile friends, do we have any questions? If you can't think of any right now, feel free to message me on Schoology. And remember, this video will be up on YouTube at 4 o'clock today, in case you need to rewatch it.